Hey folks, welcome to the Numeracy 2023 Term 4 paper. If you're joining us for the first time, the way this video works is that I go through each question and let you know how to actually do this. So the best way to watch this video is to pause the video at the start of each question, try the question out by yourself, and then unpause the video just to see how I go about doing the answers. So without further ado, let's get started. Alright, so with question 1 here, what we've got is we're selecting a tick for the compass direction of the trip from Tahiti to New Zealand. So the direction that we're looking at is this direction here. So if we go along and map that on the compass, we can see that this is going to be south down there, this is going to be west. So what we're looking for is southwest. So this is question 1A. Moving on to question 1B. So we've got the year is 2023. What is it? Around the year 1250. That's almost 800 years ago. And the tick mark for where 1250 would be on the timeline. Now, I guess you want to kind of, this is a bit of an estimation thing, right? So if you think about it, half of this distance is around 1010 or 12 or no 1011. So the way you could kind of roughly do this, I mean, if you had a ruler, you'd probably just measure it and kind of get a ratio of it. I think I do have this is not really a nice ruler, but it's still, I'm going to try and see if I can kind of get a gauge of this. All right, so roughly looking at it, 1 2 3 4 5 6 7 8. So I don't actually have a centimeter or meters in this ruler, so it's just kind of like marks. So what I've done is I've just divided that into 8 parts, the usual flight disturbance. So if I've divided this into 8 parts, roughly, right? So now half of 2023, that's going to be, 11.5, so it's going to be like 6 months. And so if you look at it, and then you've got halfway between that. So what I'm going to do is in my calculator, I am going to actually do, in my calculator, I'm going to do 3/4, so 0.75 times 2023. That's going to give me roughly 1517, right? So this part right here is 1517. So if you look at it, the closest 1250 is probably halfway between those two marks. And so we can kind of see that it is going to be the marker number 3 for this particular question. So the middle box. All right, so next question. Now, unfortunately, folks, some of the images I had to kind of get rid of. But some images I did kind of remake it, but then this one's the ones that I've remade the images, they are for, I think it just helps you, but these ones you can actually do this without the images. So what we've got is we've got a waka which is 22 meters long. So basically this thing here is 22 meters long. The small outrigger canoe is 3.6 meters long. And the question is, how many times longer is the waka than the smaller outrigger canoe? So all we're going to do is we're going to do 22 divided by 3.6. And when we get this, we get about 6.11 recurring. So I'm just going to put that as 6.1. I might put a little line there just to show that it's actually recurring. So 6.1 times longer. All right, so question D. What we've got is we've got a journey from Auckland to Hawaii, and we are trying to figure out what's the closest to the total distance on this particular trip or off the trip. So what we want to do is, and again, like this is something that you can do with the ruler. So what I would do is I'd kind of bring my ruler down, and this looks roughly 1.5. Yeah, so the way you could kind of do this is you would probably like measure out the distance and try and work the ratio out. Now in this particular case, because I don't have numbers, it makes it really hard for me to kind of give it any kind of units, because I don't think this is in centimeters, because it's a lot bigger than centimeters. So it's just, I don't know what the units for these ruler are. So I might have to actually do it slightly differently, and I know that this is going to be very hard to kind of see here, but I'm going to try anyway. So the way I'm going to do it is like, I'm going to measure this from here to here with my ruler. And I know it's not going to make sense to you, but in this ruler, it's roughly, what is it? About 1.8. So I'm almost going to put it like 1.8 units is about 3,000. Now, if you look at this question, the question is actually asking you to give an estimate, right? So we just want to know what an estimate is. So from Auckland, oh man, this is going to be fun, isn't it? So I might do it from Auckland to Tonga, which is roughly 1, and then you've got 0.8 up to there. Maybe I'm actually, no, I can't draw that right. Then we've got another 1 roughly there, maybe 0.8 up to here roughly. Again, these are all rough measurements here. 1.8. So I'm looking at about probably 3 times this. So I am probably looking around 9,000 kilometers here. So the best way to do it is, like, sometimes I use just my a thumb. A thumb is a good way to do. I would probably like place my thumb here like this. Figure out if I can actually put 2 of my thumbs together, and I just go over the maps and count out how many of my thumbs I can actually put in there. That's like, you know, it's just another way to do it. But the ruler method is probably the best one to go with for this question. Okay, so next question, question E. Waka is actually facing north. Oh, that's right, I actually forgot to write. This was one of those ones where I changed the images. So let me just write the letters. There we go. And if it turns 135 degrees clockwise without moving forward, yep, Waka is actually facing north at the moment, and we want to turn it 135 clockwise. So this, if we're going to start from north, 135 is this way here, because that's going to be 90, and then if you go all the way around, 135 is about 45. That 45 plus 90 is your 135. So you can kind of see that it's pointing towards island C. Right, moving on to question F. Don't need the ruler, let's get rid of it. Question F, yeah, I had to get rid of the image here. But basically, the idea being is sea level is 17 meters below sea level. So if you think about it like this, so there's your sea. Sea floor is there. This is 17 meters because that's like the sea. This is the floor, sea floor. Then what we've got is how many meters below sea level is Hine after she rises 8 meters from the sea floor. So from the sea floor, she is rising 8 meters above the sea floor. Write your answer as a negative number. For example, -2 means 2 meters below sea level. So if you look at it, if she's actually coming up 8 meters, there is still 9 meters for her to be kind of, to come and reach the sea level. But because it's below sea level, what we're going to write is we're going to write it as -9 meters. So the answer, you can accept the answer with or without unit. But I think you've got to make sure that you put that -9, because it actually says write your answer as a negative number. So if you write it as 9 meters, yeah, that's not going to work. I think. I don't think it'll work. Okay, so question G. Question G, what we've got is, let me just go through this. 3 flights leave from blah, blah, blah. Oli claims that compared to flight times to Fiji and Niue, the flight to Tonga takes the longest. All right, so what we've got to do is we've actually got to work out how long each of these flights take first. And then once we do that, we can actually kind of work it out. So firstly, I'm going to work out the flight time for Nadi, which is 9:55 to 1 o'clock in the evening. So that's about, so the best way to do this is like, I'll probably go to like, instead of 9:55, it takes 5 minutes to go to 9:50 from 9:55 to 10 o'clock. So 10 to 1 o'clock is 3 hours. So the Nadi flight is going to be 3 hours and 5 minutes. Then we are looking at the Nuku'alofa flight, which is 11:25 to 14:15, so 2:15. So we got 2 hours 15 plus 35 minutes. So that's 35 minutes to go to 12 o'clock. So 11:25 to 12 o'clock is 35 minutes. So 35 plus 2 hours and 15. So that's going to be 2 hours and 50 minutes. Then we got 8:15 to Alofi, 8:15 to 11:45. So that's going to be 3 hours and 30 minutes. Now, once that's done, what is Oliola claims that flight times to Fiji and Niue, bad flight Tonga takes the longest. Right. I think we can actually kind of say that Oli is incorrect because Tonga actually takes the shortest time. It only takes 2 hours 50 minutes compared to Fiji and Niue. So we probably will say Oli is incorrect. As flight to Tonga takes the shortest time. Flight to Tonga takes the shortest time. Looking at the answer schedule, it says must be supported by calculations for at least 2 destinations, which we've done. Yeah, that's pretty much it for question 1G. Let's go to 1H. All right, so 1H, what we've got 1,000 New Zealanders were asked, are you hoping to visit Samoa this year? People who said yes were asked, what is your reason for going to Samoa? Graph shows these data. Select tick for all the statements that are true about 1,000 New Zealanders. There is more than one answer. So they are actually telling you that there's actually more than one answer. Now, if you look at it, 10% of the people were hoping to visit Samoa this year. Are you hoping to visit Samoa this year? 10%. Well, that's kind of true there, because if you look at it, we can see that percentage is 10%. So 10% of people hoping to visit Samoa this year. I can say yes, that's correct. Next is 200 people were not sure if they would visit Samoa this year. Okay, so if we look at not sure, I'm going to put this in a different color. Not sure is 20%. So if you actually work out what 20% of 1,000 is, and the way we're going to do this is we're going to go in the calculator 20 over 100 multiplied by 1,000, and that's going to give me 200. So that's kind of correct. 200 people were not sure if they'd visit Samoa this year. That's actually correct. The next one we're going to be looking at is 500 people were hoping to visit Samoa to have a holiday. What is the reason? Now, if you look at this particular one, this is actually a trick question, all right? Because when you look at that 50% of holiday and you go, oh yeah, it's 1,000 people going. But if you think about it, the pie graph is actually for only the people that actually said yes. Because it actually says here, the people who said yes were asked, what is your reason for going to Samoa? Now, that means only 10% of the people actually responded with what's your reason for going to Samoa. So in other words, for this one, we had 1,000 people. But out of the 1,000 people, only 100 people said yes. And the pie graph is actually for the 100 people. So bullet point, the third option, 500 people were hoping to visit Samoa to have a holiday. That's not true. Now looking at the fourth bullet point, about a third of the people hoping to visit Samoa this year were going to visit family or friends. About a third of people were hoping to visit. So that means we're looking at this part here. And it's, you know, and it's kind of correct because about a third, it's not exactly a third. About a third is actually close to 30%, because if you think about it, a third is actually a third as a percentage is 33.33%. So in this case, I would say yes, the last bullet point is actually correct. Now, in the answer schedule, it actually says you need to have 2 of these questions correct. Well, 2 of them right, but you definitely cannot include C. And that's a wrap for question 1, folks. We go to question 2 next. All right, folks. So we're now going to question 2. So question 2, what we've got is a diagram of a basketball court. Well, we know basketball court is a rectangle. And we've got 15 by 28. And we're looking for the area in square meters. So that means we're going to do, let's just change the color, 15 times 28. And that's going to give us 420 meters squared. That's pretty much question 2A there. Now we go to question 2B. So 2B, we've got, let's just kind of make this basketball. Here are the players in the basketball team. Their heights are given in meters. Which two players need to swap places so that the heights are in order, shortest to tallest? Looking at this, we've got 1.57, 1.6, 1.94. So definitely Kendra's got to move here. And definitely Tanya has got to move there. And I think if we move Tanya to 1.61, so Tanya could actually come to where Kendra is, and Kendra could go to where Tanya is. And that's because of the decimal numbers. So if you were to put them up, right? So you've got 1.57, 1.60, which is the same thing as 1.6. Then you would get 1.61, which is Tanya, 1.70, 1.78, 1.80, 1.94, and finally 2.01. So as you can see, Kendra and Tanya need to swap places. I don't think it matters which way you write it, so you can actually just go Kendra and Tanya, and that's absolutely fine. All right, so the next question we have, basketball game is 40 minutes long. Coach wants all 8 players to get equal time on the court, but only 5 players can be on at one time. The coach thinks that each player should get 30 minutes on the court. Is he right using calculations? All right, let's have a look at this. How do we go about answering a question like this? Now, each player should get, he says, 30 minutes time. There's a couple of ways of doing this. We could actually do it first, what's the optimal time, right? So then from there, we could actually work it out. So let's actually start with this. Now, we've got 5 players and there is 40 minutes long. That means each position, when you put it all together, there's 5 positions, right? So 5 positions times 40 minutes. So we'll actually work that out first. So 5 times 40 is equal to 200 minutes. Now 200 minutes is the actual game time itself, but we've actually got 8 players. So if we want 8 players to have equal amount of time on the court, then we need to do 200 divided by 8. When we do 200 divided by 8, we actually get that each player should actually get 25 minutes each. And with that, we can actually say the coach is actually incorrect. So coach is actually incorrect, as each player needs 25 minutes to get equal game time, or something along that lines. Right, let's go to question D. Gotta love AI imagery. That was the best I could do, by the way. Best angle for a jump shot is 48 degrees. In the image below, the arrowhead that is closest to the angle. All right. So looking at this, 1, 2, 3, 4, 5, 6. I kind of just started putting some random kind of lines here. But 48 degrees is pretty close to 45 degrees, which is halfway between 0 and 90. So, and I know I said arrowheads, apologies, because I would probably think that right there is probably the closest to the 48 degree angle. And that's pretty much it for question D. Let's go to question E. All right, question E, Lucy plays basketball. She plays, her average success rate for a free throw is 50%. Lucy is taking 2 free throws, one after the other. She's very confident one of her shots will go in. Do you think she's right? Explain your answer using ideas about chance. Okay, so one thing that I would recommend is, like, I mean, if you just think about like very basic probability tree, you can kind of look at that. So if you look at it like this, she takes her first shot and it's a 50% chance that it's actually gonna actually make it, right? So we might put this as success, failure, that's 50%, and then success, failure, success, and failure. So all of her, it's all 0.5, 0.5, 0.5, or you can write it as half, half, half. I think let's actually do it as halves. Should have done that from the beginning. So that's a half, 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 1.5. Now, she says that she's very confident that one of her shots will go in. So what we have for this particular one is that, let's have a look at this, all right? If she gets 2 shots in a row, that's going to be a 1 in 4 chance that she gets two shots. Now, if you don't do a probability tree, and you haven't actually done a probability tree, you can actually do it another way as well. The other way to think about it is like, so she takes 2 shots. So these are all the situations that could actually happen. So she makes the first shot and the second shot, or she makes the first shot but misses the second shot. So I'm going to put that as a fail. She fails the first shot but makes the second shot, and then finally she fails both shots. All right, she misses both of the shots. And if you look at it, you've got 4 possibilities that could happen, and 3 out of the 4 possibilities, she is actually going to at least make one of her shot will definitely go in. So it's like a 75% chance that one of her shots will actually go in. So what you want to say is something like, you can actually say 3 out of 4 chance of making one shot. So therefore she's right. Now you can actually do it with a probability tree as well, or you can actually write down all the options that could happen and then kind of work out your probability from that. Now, looking at the answer schedule, if you think her idea is not going to work, then you actually have to support it. You know, and it's kind of tricky, right? Like, I mean, thinking about how you would actually reject it, especially when she has such a high chance of making at least one shot. In terms of unacceptable answers, they say it is just luck. You can't actually write that. You can't write there's no way to predict what might happen, and you can't actually write if one misses, the other will go in as well. So none of those things. So you have to have some sort of probability tree or some sort of chance thinking, and coming up with that 3/4 chance of making one shot will probably be your best bet to get this question correct. Okay, so 2F, we've got graph shows the most popular sports among students in New Zealand in 2022. Girls, boys, wow, netball really kind of stands out. What was the approximate total number of boys and girls playing basketball in 2022? So basketball, we're looking at just basketball. So that is roughly there. We probably could say around 6.5, 7, and that's about roughly halfway there. So I'll probably say 6,500 plus maybe 17,500. That's going to give us 24,000 approximately. Looking at the answer schedule, it basically says that accept answers between 23,000 to 27,000. Yeah, so it's with 24,000, which is kind of like a little bit more towards the lower end, but that's okay. That's still correct. Folks, and that's basically question 2. Now I know you're looking at this image and going, what the hell is this? But you know, some images are generated, but like this one, I was like, you know what, I just can't be bothered. It's just trying to get an image of a woman looking this way. It was just too much work. You know what? There's my stick figure. That's it. We're going to work with that. All right, so let's have a look at question 3 here. Mia is shaving her hair, 1.72 meters tall. Distance from the ground to her hair is 89 centimeters. What is the length of Mia's hair in meters? So what we're going to do is we're going to go 1.72 meters minus 89 centimeters is 0.89 meters. So that's what we're going to do in the calculator there. So we've got 1.72 take away 0.89. That's my dog Watson. 0.83 meters. All right, so we've got 0.83 for the final answer. Units are actually not required for this, so you're pretty much good to go after that. So, secondly, we've got 3 options for donating shave or cure. How many transport to hospital donations will raise the same amount as 10 support person donations? So 10 support person donations is 10 times 55, which is $550. So then we've got to go $550 divided by 22. So let's go 550 divided by 22 equals 25. So then we're going to have 25 transport to hospital donations. Yep. So 25 of them is what is going to get us to $550. All right. So that's question 3B. 3C. This bar shows the donations that Mia has received. How much has Mia received in donations? Now, again, this is a bit of a tricky one here, but like the best way to do this is I'd probably use the ruler again and try and come up with some sort of scale here. So I'm gonna try, not guaranteed to get anything here, but so 1, 2, 3, 4, 5, 6. Looks like roughly 6.5. So 5 out of 6.5. So, and again, this is just my ruler, which is terrible. So 5 out of 6.5 is what the proportion is. So I'll probably go 5 out of 6.5. So I'll probably go 5 divided by 6.5. And I would multiply it by 800. I got roughly $615. Now, this particular answer, you can get a range of $600 to $680. And they're okay with you getting a range of $600 to $680. Cool, that's question 3C. Then we go to question 3D. We've got the graph that shows the amount given by Mia's donors. How are the amounts donated by schools? Students differ from the amounts donated by adults. All right, so let's have a look at the graph here first. Now, looking at the graph, you can kind of see the yellow dots are quite at the far end. So we can already see that the adults actually donate, generally give a lot more than the school students. So we're going to say that adults give more than students generally, or whichever way you want to write it. But we still need to give some sort of supporting evidence, right? Now, the first part of evidence that you could give out here is you could actually try and work out what the median is, like what the middle number for the adults and the school students are. The other one you can also look at it is like how there's a huge amount of cluster here for the adults at the higher end, as for the school students, their cluster is actually at the lower end. So you could actually talk about how the cluster is like there's a big cluster for the adults, but for the there's also a cluster for students, but that's actually in the smaller donation end. So you can talk about that. The other thing you can talk about is also the median. If you look at it, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 adults. So we've got 11 adults, which means to find the median, we're going to go 11 plus 1 divided by 2, which is 6. So 1, 2, 3, 4, 5, 6. So you can kind of say roughly, what is this? Is this going in twos? I think this is going up in twos. 2, 4, 6, 8, 10, 2, 4, 6, 8. I think I could be completely wrong here, but I'm going to say that's definitely not $20. Maybe it'll be $22 for adults. So you can actually say median for adults is 22. Then we're going to look for the students. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we've got 15 students. We're going to go 15 plus 1 divided by 2, which is 8. So 1, 2, 3, 4, 5, 6, 7, and 8. So we can see that the median for students is around, have I done this right? Hang on, let me just check this. 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, 8, 1, 2, 3, 4, 5. So I'm thinking as around median for students is around 15, 16 maybe. Yeah, I'll probably put it as 15 or 16. probably more 16 than anything else. Interestingly enough, the answer schedule actually says that median for school students is about 13. I don't know if that's 13, because especially 13 is definitely not going to be this close to 20. I'd actually think it's 16. So you could actually use this to support your claim that the adults give more as well by comparing their median. That's another thing you could potentially do. All right, so going to question 3E. Mia, yep, beautiful image here. Liberty wigs, $200 for minimum length of 35 centimeters for every extra centimeter after that. So Mia sells 70 centimeters of her hair. How much money will she make? So for the first 35 centimeters, she is going to get $200 plus $4 for every, so 4 times the remaining 35 centimeters. So she's got 70. So you go 70, take away 35. That's where $200 comes from. So then we've got 200 plus 4 times 35. 200 plus 4 times 35. That's going to give you $340. Now, interestingly, one of the answers that they actually accept is actually 2 times 200, which is $400. So, yeah, if you actually think about it, right? Like, you know, if you're trying to be smart about this, you probably will cut your hair into 2 lots of 35s. Because that way you actually get a lot more money than selling it as a single wig, which is like 70 centimeters. And I guess that's the reasoning behind why you can actually accept the 2 times 200 as $400 as one of the answers as well. That's us for question 3. We go to question 4 next. All right, folks. Now we're going to go to question 4. Now the first question is that we've got 300 meters by 300 meter paddock or farmer's field, and inside there's a 30 meter by 30 meter section. There's 5 cows. So the question is, estimate how many cows there are in the whole field. Now, if you think about it, each of these little squares is 30 by 30. And that means we can actually fit 10 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Ugliest square that you can possibly think about. But how do I know it's actually 10? Because I can actually go 300 divided by 30. That's going to give me 10 here. 300 divided by 30. That's going to give me 10. So altogether, I have 10 times 10, which equals to 100 squares. 100 of the little squares. 100 of these highlighted yellow squares, which is right there. Now, if each of those squares has 5 cows, then I'm going to do 100 times 5, which is going to give me 500 cows. So that's pretty much it for question 4A. Next, we go to 4B. Here's a picture of Daisy, 183 cow. Daisy sees a reflection in the water. From the options below, select the picture that shows the reflection Daisy sees. Now, if you look at these reflections, obviously the number is going to be reflected. Now, in this case, that number is not reflected, so it's not going to work. In this one, it's not the reflected image. And then in the last one, you actually see that 183 is actually the right way up. So the correct answer we're looking for in this case is basically this one here, because both of those numbers are actually reflected. Cool. Let's go to the next one here. Question C. Question C is, on average, dairy cows walk about 12,000 steps a day. Each step measures about 1.6. Farmer claims that each of her dairy cows walk 20 k's per hour. So let's actually work this out. So we're going to go 12,000 steps per day. Each step is 1.6 meters. So then we're going to go 12,000 multiplied by 1.6. Now, when we do this, 12,000 times 1.6, we are going to get 19,200. 19,200 meters, or this is also known as 19.2 kilometers. So this is one of those weird questions where you can actually say yes, you know, it's kind of reasonable because 19.2 k is actually close to 20 k. So you can say yes, it's reasonable. And it's, again, when I said it's one of those questions, like, you can also say no, she's not correct. Her claim's not reasonable because they're not actually going 20 k's. They're only going 19.2 k's. So whichever way you write this answer, you can write it either way, but you must have the 19.2 kilometer calculation. You have to show that calculation to make that claim. All right, so this is one of those yes or no questions. So if you say yes, you need to give the reason as to why you think it is. If it's a no, then you need to give the right reason as well. And look, like I said at the start of this question, it is one of those questions where you can go either way. As long as you give the reason, you're pretty much good to go. All right, question 4D. Mulu cow produces 35 liters of milk per day. Family uses 3 liters of milk every 2 days. Approximately how many days will 35 liters of milk last that family? So they use 3 liters for every 2 days. So this is, now there's a couple of ways of doing this, right? I mean, you could actually find out how much milk they use per day. So if you do that first, so if you go 3 divided by 2, that gives you 1.5 liters per day. So if they have 35, then we're going to go 35 divided by 1.5. 35 divided by 1.5 is going to give us roughly 23.33. So approximately how many days? You could just write down 23.3 recurring days. You could also write it as 23 days, or you could write it as 24 days as well. Something to keep in mind. And again, this question, you might actually say, well, 24 days is not possible because it's rounding up. But yeah, it's just, they'll have a little bit of milk on that 24th day, wouldn't it? But anyway, 23 to 24 is fine. We go to the next one. Okay, so we got about 6 million cows in New Zealand. Looking at the graph above, how many cows in New Zealand are Jersey cows? So first off, we've got actually working with a percentage here. Now, looking at this particular percentage, tricky. You could say 8%, you could say 7.5%. I'm going to go with 8% just for the hell of it. Okay, let's just go 8%. How many cows in New Zealand? So 8% of 6 million is what we are trying to work out. The way we do this, we're going to go 8 over 100 because that's what 8% is. And we're going to multiply it with 6 million. So it's not going to work. So we got 8 over 100 times 6 million. There we go. And that's going to give us around roughly 480,000. Now, looking at the answer schedule, they've actually said that any answer between 400,000 to 500,000, they will actually accept. They also said that calculation is not required. So just an answer is straight up all good. But what you can't do is you can't actually write percentage answers. So you can't actually say 8%. You actually have to work out what that 8% is. Cool. Let's go to question F. Now the question F is farmer's herd has 300 Holstein, 200 Jersey. There is no pattern to which cow turns up first to be milked. Farmer says there's a 60% chance that the first cow is Holstein. Is she right? Now, what we've got is we've got 500 cows in total. What we have is 300 out of these 500 cows is actually Holstein. So if you work this out as a percentage, so if you actually go 300 divided by 500 multiplied by 100, you're actually going to get 60%. So straight away, you can pretty much say that farmer says a 60% chance. Is she correct? Yes, she is correct. And she's correct because there is only 60% of the cows are actually Holstein cows. So there's nothing else that you can do with this. And that's question 4. All right, folks, we're on to question 5, which is the final question of this particular paper. So voting determines the people, blah, blah, blah. What is it? Elections in New Zealand happen every 3 years. 2023 is an election year. Was 1987 an election year? Show your working to you use to answer this question. Now, you might actually do it the old-fashioned way, which is actually go 2023 minus 3 and just keep going till the end. Yeah, there's just so many ways of doing this. So like what I mean by is like you could actually do this 2023. No, hang on, let me just do this. We're gonna go 2023. Yeah, so we're gonna go 2023 minus 3 equals that. And what I might do is I might just go answer minus 3. So here we go, answer minus 3. And I could literally keep going back. And there we go. 1987 was actually an election year. So the way you could do it is you could actually write down all those answers. All right, that's one thing. So we're going to say yes, it is, or it was, sorry. And the way you might have done it is 2023, 2020, 2017, 2014, 2011, 2008, 2005, 2002, 99, 96, 92. I feel like I've made a mistake somewhere. Have I? 23, 17, 14, 11, 8, 5, 2, 9, 6, 92. No, 92 is where I made my mistake. There we go. 93, 1990, 1987. There we go. Best of times and worst of times when you make mistakes like that. So that's one way you could show it, but as long as you show some sort of method is fine. The other way I would have done it also is gone 2023 take away 1987. That's given me 36 years, and 36 is actually a multiple of 3. So there's been 12 elections since 1987. So that's another way you could also answer this question. Question B, we've got 72 electorates in New Zealand, includes 7 Maori electorates. 3.9 million people can vote. Select the equation that gives the average number of people per electorate. Oh, okay. Well, that's just 3.9 million divided by 72. So that's fairly straightforward one, because this is just a division question, right? So we've got total number of people, 72 electorates, and we just want to know how many number of people are in each electorate. So we just go 3.9 million divided by 72. Okay. Question C. What is it? We've got 120 seats in Parliament. Right. Apple Party receives 35% of the votes, so they get 35% of 120 seats in the Parliament. That's 42. How many does Orange Party get? Now, Orange Party is on 15%, so we want to work out 15% of 120. So it's 15 over 100 times 120. So 15 over 100 times 120. And that's going to give me 18 seats for question C. Question D. To be the government, parties need to work together and form a team called coalition. Team must have over 50% of the seats in Parliament. Apple's at 35, Orange is at 15, Bananas at 45, and Kiwis at 5. Oh, clearly a stalemate here at 50% each. Okay, select all the teams that could form the government. Now, Banana and Orange, 45 plus 15. Yes, they're going to be fine, because that's going to be 45 plus 15 is 60. They're fine. Apple is 35. Orange is 15. That's not going to work. That's only 50%. And it's got to be over 50%. Kiwi fruit is 5. Banana is at 45. That's not going to work. Apple's at 35. Banana is at 45. Definitely going to work, because 45 plus 35 is 80. Orange and kiwi fruit, 15 plus 5. Nope. Orange is 15, kiwi is 5, apple is 35. 15 plus 5 plus 35, 55. So they're going to be all good to create a coalition there. Okay, and we go down to the last question here. Every voter in New Zealand, Aotearoa New Zealand, makes 2 choices. They vote for a party and then they vote for a person. One combination is to vote for the Banana Party and then Isaiah Finaki. Another is the Orange Party and Henry Chot. So the question is, how many different voting combinations are possible in this form? Okay, so if you think about it, we've got 4 party votes and 6 person votes. So if you think about it, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Or in other words, to find this, we just have 4 times 6, which equals to 24 voting combinations. And folks, I think that's basically question 5 for us. So folks, that's basically it for this particular paper. Now, if you do have any questions, throw it up in the comments. Any kind of feedback, I appreciate it. And also, if you are watching this video up to this point and you actually managed to get up to this point, please do share this video, because a lot of year 10s actually don't know I exist and I make these resources, and they're available for you at any time. I guess the biggest thing for me is that sometimes people find this channel a bit too late. So, you know, if you do have any folks or friends that you know that are doing the co-requisite, or even if they're in like year 9 or year 8, just send them this and let them know that I do exist. Yeah, that's pretty much for me.
Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.